Well, Chapter 7 talks about automatic sprinkler systems. This chapter is probably the most important chapter that you'll read in the book and from Reese Jones. He goes into detail in regards to the various things, and one of the things he starts looking at is the introduction and underground systems that supply water, sprinkler systems, the components, as you can see here, and he also starts seeing the gauges, and you start seeing how the systems are put together: water control valve, drain valves, isolation valves, pressure reducing valves, which we definitely need sometimes on our standpipe systems. We also have the components in which NFPA 13 come about, and also too that the sprinkler heads are designed. You'll have old versus new, and we have all kinds of things that deal with that now, and how we take and control a sprinkler flow when a sprinkler head goes off as a firefighters. What we use, there's tongs and there's wedges, all kinds of stuff that helps control the flow of a sprinkler head. We've got the systems that are out there and they're complex, but at the same time, they're very simple. Water comes in and water goes out. I mean, I don't know what else I can say about that. But the big thing is look at a water system, sprinkler system that's wet. It's a grid system. Water comes up, water goes through the grid, and it sits there and waits to be activated. And once it's activated, the head pops off, water comes out. The big things is there's other types of systems. The dry system, where there's systems under pressure, where water is held behind by a baffle, and all at the same time when the head bops off and all the air releases out, the baffle opens up and water comes through the system and the whole system becomes wet. That is some of the stuff that you probably see every day. The systems are very similar. The grids laid out the same, but what you come into is how the fire department, OSMY valve, and the pressure system and the connections are all come together, where the water comes into the sprinkler system and how it goes in, distributed through the distribution center. So you got all kinds of things. The biggest thing we're looking at today is some pre-action systems, where you have a sensor that goes off, or in this particular case, a smoke head goes off and the system's activated. Automatic water comes out. That's pre-action. The big things you also have is deluge systems, where if you take and have one head go off, they all go off. And that's generally what you'll see in some electrical, hydraulic, and pneumatic systems that are out there that need fast protection quickly. Sometimes you'll see this more in an industrial setting. An industrial deluge system is designed to do one thing: dump a lot of water quickly. And that's what you see a lot of times. Uh, we get into requirements about NFPA and then the ICC code. Occupancy load, building heights, and storage are all part of what goes into what the design of a sprinkler system is. Big thing is 13D and 13R are all part of the design mechanism from under the NFPA code. And the big thing is how they have to perform and be maintained. The other thing is you got installation systems in 1 and 2 family dwellings, and how they're also how they are designed through NFPA 13D. You also have 13R for low residential housing, which is actually where we have the home sprinkler systems that we want to see out there today. And then, of course, you got design, installation, and you got NFPA 30, 30B, 214, and 804. All are specific design requirements that the insurance company may want to be involved in as far as development. And they also develop the standards, meaning they're protecting a commercial property or an industrial type complex. And they say, well, look, we want this type of protection system under NFPA 13. However, we want to add these other fractions to it. So they go in and define it under 30, 30B, 214, and 804. The big thing is how the system's classified. You'll see the hydraulic system chart on the system. I'll tell you exactly what it is, what it's been tested for, and what's the density and the square footage that it's going to cover. In this particular slide, you see that 1950 is the square footage that it's going to discharge out to. So it gives you a good idea. One of the big things is you start looking at there is what is the hazard, what is the density, and what is the supply of water needed to make the sprinkler system work. This is where you have to look at the calculations, and a fire protection engineer needs to say that. Along with, guess what? the building engineer, the person that's going to engineer the building. And one of the things you have to look at is this particular valve that you see right here is what they use in a standpipe. Do we need to put pressure reducing valves on the standpipe so the firefighters don't get blown away when they hook a hose to it? Most of the time you run into a situation where the standpipe's supposed to maintain 50 to maybe 75 pounds pressure, and it's blowing at 150, 200 pounds, and you hook a 2.5 to that, you're going to be flying through the building. So the big thing is, in summary of all this real quick, is the fact that the automatic sprinkler system is what we see every day in our lives in commercial buildings, and now we're starting to see it in residential, and also we're seeing it in multifamily dwellings. Think about mixed use now. You have retail on the first floor or some sort of professional offices or whatever, and then residential components above that. Now you get into two different types of sprinkler systems, a commercial application, and then you get into the residential application, and that code is allowed to do that. And you go from one type of system to another. Think about the hotels that are on top of an office building. Same thing. Two different applications, two types of systems that you'll see. So it's interesting. They're all sprinkler systems, but do you see the difference in the piping, the type of heads that go in, and also to the type of systems that has to be maintained. So this is a good chapter. It's a good read. Take your time and enjoy yourself. Thank you.